Good morning, everyone. Today we're going to discuss about oblique asymptote. So an oblique asymptote is also called a slant asymptote. An asymptote is a line that your graph tries to approach but will never touch. Oblique asymptote happens when the top degree is greater than the bottom degree. When we say degree, it means that it's the highest power of x. In this particular case, the degree on top is 2 and the degree at the bottom is 1. So therefore, because the top degree is higher than the bottom degree by 1, then there is an oblique asymptote for this one. We can find the oblique asymptote by dividing the numerator with the denominator. The first step is for you to get the first term of your dividend and divide it with the first term of your divisor like this. So 2x squared divided by x is 2x. Whatever answer you get there, you're going to put it here. Notice that just for organization purposes, I have placed it on top of the 15x because this is also x. On your way down, you're going to multiply this to both of the terms. So 2x times x and then 2x times 7. 2x times x is 2x squared. And then 2x times 7 is 14x. And then you're going to subtract. All right, so 2x squared minus 2x squared is 0. And then 15x minus 14x is 1x. Understand that in front of this x is a coefficient of 1, which I'm not required to put, but is understood to be there. After this process, you're going to bring down the positive 12. The next process is you're going to again take the first term here and divide it by the first term of your divisor. I always recommend the side of your paper as your scratch work in order for you to see clearly what's happening. So x divided by x is equal to 1. You're going to put it here. You're going to put positive 1. On your way down, you're going to multiply this number to both of the terms. So 1 times x is x, then 1 times 7 is 7. So 1 times x is x, 1 times 7 is positive 7. You're going to subtract. X minus x is 0. And then 12 minus 7 is 5. Since I don't have any more number to bring down, this is your remainder and it should be written as this. So whatever is the sign of 5, which is positive, you're going to put it there. You will put 5 over x plus 7. And this is your whole quotient. When you get to this point, your oblique asymptote or your slant asymptote is the linear part of your expression. So this is your asymptote. Let's go ahead and consult Desmos on this one. Let's plug it in and see what happens to your graph. Alright, so plug in your whole equation from the very beginning, which is 2x squared plus 15x plus 12 divided by x plus 7. When that happens, then this graph shows. When you plug in the linear part of your expression, it is going to show you that y is equal to 2x plus 1 is your oblique asymptote. Now let's talk about the behavior. So because your graph looks like this, as your x approaches infinity, which is moving to the right, okay? As your x approaches infinity, your graph or your function approaches the line which is y equals 2x plus 1, which is your asymptote. And that is approaching it from the positive side. Let's take a look at this side. As your x approaches the negative infinity, which is going to the left, your graph or your function approaches the negative infinity. You are free to review this video or rewind this video in order for you to see the graph again. But the behavior of your graph is as x approaches the positive infinity, which is moving to the right, your function approaches the line 2x plus 1 from the positive side. And then, as your x approaches negative infinity, your function approaches the line 2x plus 1 from the negative side. Again, this is how your graph looks like. Let us extend the lesson and find the vertical asymptote. So get the denominator of your function and set it equal to 0. So your x is equal to negative 7 and that is your vertical asymptote. Let's plug it in on Desmos. All right. So this is your vertical asymptote, which is at x equals -7. Example number 2, negative 3x squared plus 6x plus 7 over x minus 2. Again, if the top degree is greater than the bottom degree by 1 point, which this is because this is 2 and that's 1, so 2 is bigger than 1 by 1 point, then we have an oblique asymptote. So let's generate the oblique asymptote by using the long division. Get the first term of your dividend and divide it by the first term of the divisor. So negative 3x squared divided by x. Once again, I recommend that the side be used as a scratch work so that you can clearly see what you're doing. So according to this, negative 3x squared divided by x is negative 3x, and we will put it here right on top of where the x is. On your way down, you're going to multiply this to both of these terms. So negative 3x times x and then negative 3x times negative 2. Negative 3x times x is negative 3x squared. Negative 3x times negative 2 is positive 6x. You're going to subtract them. Negative 3x squared minus negative 3x squared is 0. You will cross that out and cancel that out. Positive 6x minus positive 6x is 0. You will have to put that 0 down. And this is a weird example, so I'm going to show you how to do this. So write down 0 and then bring down the positive 7. The moment you bring down a number, you'll have to use this first term to divide this by. That's just how division goes. So as you can see here, there's a 0. You will still have to do 0 divided by x. So 0 divided by x is 0. You will put here 0. So plus 0. And then 0 will be used to multiply for both these terms. Right? So this is 0 and 0 times x is 0 and 0 times negative 2 is 0. Then you will subtract again. Okay? And 0 minus 0 is 0. 0 minus 7 minus 0 is 7. And so once again, we cannot bring down anything anymore. And so this is called your remainder. You will write your remainder as the sign of 7 is positive and then 7 over the divisor. So therefore, this is your quotient. And we are now about to get our asymptote, our oblique asymptote. All right, so since this is our quotient, again, we're going to get the linear part of our expression, and the linear part is negative 3x plus 0, or simply negative 3x. This is now your oblique asymptote. All right, so let's take a look at how your graph looks like. And this can be done by plugging in your original problem, which is y equals negative 3x squared plus 6x plus 7 all over x minus 2. When you plug this in, let me turn this off first. When you plug this in, this is how your graph looks like. And when I plug in the asymptote that we got from here, this one, the negative 3x, of course, I had put a y. Okay, so y equals negative 3x, then the line or your slant or your oblique asymptote shows up. Again, that is negative 3x. If some of you are bothered why there's no 0, I will put the 0. It's the same thing. Now, our next thing is we're going to extend the lesson and find the vertical asymptote. Alright, so once again, let us remind ourselves. The vertical asymptote can be found by setting your denominator equal to 0. So which I did, x minus 2 equals 0. So your x is equal to 2. Let's plug this in and see how our graph looks like. Alright, so the purple line is your vertical asymptote and the blue line is your oblique asymptote. The red is your graph, is the graph of your function. So let us look at the behavior. Let's turn up the vertical asymptote first. So let's take a look at the behavior. As your x moves to the right, and of course it's very difficult for you to imagine that this, where my arrow is moving to the right, because this is so like almost like vertical. So this is, as this goes to the right, your graph or your y approaches your line from the positive side. Once again, I'm encouraging you to play back this video in order for you to see the behavior of the graph. But for right now, the behavior of our graph is said to be when the x approaches the positive infinity, which means that your graph is moving to the right, your function or your y values are approaching the negative 3x line from the positive side. shown by this right here. Okay, now let's take a look at this other side, the negative side. As your graph approaches, uh, the negative of the x, the negative infinity, which means to the left, as your graph goes to the left, your function approaches the line x equals -3 from the negative side. So as x approaches negative infinity, your function approaches, or your y, that's the same as y, approaches the -3x line from the negative side.